Solving systems of linear equations with the elimination method. You can also hear it referred to as the addition method. The elimination is, out of the three major methods, graphing, substitution, elimination, I believe this is probably most people's favorite. It works the most often. It's the easiest way probably to avoid fractions or decimals, but not always. So the elimination works like this. I can actually add a whole equation to another equation. So what I can do is I can actually add these up vertically, okay, and combine the like terms. And if you remember, the big issue with solving a system of equations is I need to find two unknown variables. And this is very challenging to do. So if I can solve for one at a time, that's really the goal. So watch what happens when I add vertically. So if I add this one and this one, that's 2x. Positive y and negative y is 0, and then that equals 18. And I'm down to one variable. Solve for x, and x equals 9. Now I need to find the y value, and it doesn't matter which one I plug into, either one. I'll plug into this one. Alright. Oh, sorry, I plugged into the wrong point. But it's going to come out the same answer. Okay. And y equals positive 1, so that's my answer. 9, 1. Okay. Well, that worked out really nice. Well, there was a unique situation that made that happen, is I had some opposites. Okay, so this elimination method only works if I have the same values but one positive and one negative, or we have what we call additive inverses or opposites. So if I don't have opposites, it's not going to work. So let's look at this next example. So if I look at this one, if I add vertically, I'll get x, negative 2y, and 7. The whole goal here is for one of the variables to go away. So in this case, I got to make the opposites happen. And this is the one difficult part of the elimination method. So what I would like is, so I would like things like this: a 2x and a negative 2x. I'd like a y and a negative y. I need some sort of opposite like that, right? Those are opposites. So in this case, it's actually easy to go either with both of those options. So I'm going to make a decision. I'm going to decide to eliminate the y's. Okay. So what I want is a positive y and a negative y, and I don't have that. So it doesn't matter which one I pick, but I'm going to make it happen. So I'm going to take this top one and I'm going to multiply it by negative 1. And I'm going to come down here and rewrite both equations. So I get, using my distribution property, okay, and I can do that because I did it to both sides of the equation. Then I'm going to just rewrite the second one. Okay. So now I have opposites. And I'm going to add those up, and I get 3x equals negative 9. And x equals negative 3. Okay. Now remember, I need an x and a y. Okay. So I'll go ahead and I'll plug in over here, and I'll go, I'll plug into this one. It doesn't really make a difference. So 2 times negative 3 minus a y equals negative 1. That's negative 6. Add a 6. Divided by negative 1. Okay. And there you go. So I could have multiplied this one by negative 1 as well, and it would have worked out exactly the same. So you have some leeway in how you do it. Okay. Now in this particular question, I have the same issue. I don't have any opposites, and I want to get, it doesn't matter x or y, and I'm going to actually have to multiply both equations to make it work. So I got to decide, do I want to get rid of x or y? Well, last time I got rid of y's, so I'm going to get rid of the x's. So I got to look for an LCD, okay, or at least common denominators way here, or at least common multiple is probably a better way because we're not looking at a fraction. But so if I look at it, 2 and 3, if I look at the multiples, the first number, that they turn into is 6, right? 2, 4, 6, 3, 6, 9. So, but I need one to be positive and one to be negative. It doesn't matter which one. So I'm going to go ahead and, I don't know, I'll make the top one positive and the bottom one negative. So I want to get to a plus. What I really want is this, a positive 6 and a negative 6. So I'm going to multiply this top one by 3. Okay. And I'm going to multiply this bottom one by negative 2 because I'm trying to get to 6 and positive 6. Okay. So looking at this, I get 6x, and don't forget to distribute, plus 9y, and 3 times 7 is 51. Down here I get negative 6x minus 8y, and that gives me negative 48. Okay. So now I've created the opposites, those cross off, I get y equals 3. Okay, so now I got to go back and solve for x. So, and it doesn't matter which one I plug into. I'm going to go ahead and plug into this one before I multiplied by 3, so basically what I have in black there. So it's going to be 2x plus 3 times 3 equals 17. So here's my answer, or the first part of it. So I get 2x plus 9 equals 17. Subtract 9 of both sides. 2x equals 8. Divided by 2, and x equals